I wanted to take a minute to go through and kind of walk you through the activity for today in case there were some questions, because there are a couple different steps to it. So the first thing is your name. If you have a question about your name, that's a whole different conversation. Hopefully that is not a concern that you have. Okay, so in this illustration, there are 4 different objects with 4 different densities. Each of the squares takes up the same amount of space, similar to volume in 3 dimensions, but there are fewer particles on the left, so it is much less dense. The box on the right shows tightly packed particles, which make the box on the right move much more dense than any of the other squares. The amount of particles in an object is its mass. More particles means more mass. The box on the far right has the most particles in it, so it would have the most mass. The box on the far left has the fewest particles, so it would have the least amount of mass. Reminder, volume is how much space an object takes up in 3 dimensions, length times width times height. If 2 objects have the same mass but take up different amounts of space and the object takes up less space, will have a greater density because the particles are packed together more tightly. The 2 objects on the scale have this exact same mass, but the one on the left takes up to 10 times more volume as the one on the right. That means the particles in the one on the right have to be much more tightly packed together, which means it is more dense. Okay, we're gonna start. I'm not going to watch the video, but you can watch the video about density. To calculate density, density is mass divided by volume. Now, to do this, I right-click and I open the link in new tab. If you are not using a mouse, if you hit the bottom right tab part of your pad, it should be the same as a right-click. This way I have access to my simulation that I want to use. Now, it may give you a problem with Flash Player. It's easy to get through, so if I click to enable and I allow, it lets me in. I think most of your Chromebooks already have that process done because we've done some things on Flash Player before. So what you want to do is set your key to mystery. Okay, and it gives you all these blocks, and we have a table, we have a scale. And we're only going to do 2 blocks. You can play around with this when we're done with this if you want. But this is going to show us 2 measures of material, and that's going to help us find the density of the material. So we're going to start with box A. So I pick up box A and I put it on my scale. I see that it's 65.14 kilograms. Take it off. I can confirm that. Now, when I place it into the water was at 100 liters. It went up to 3.38 liters. So that's our first question. It says box A moves on the scale. It has this put box A on the scale. We saw that it had a mass of 65.14 kilograms. Drop it into the water. The water moves from 100 liters to 103.38 liters, which shows it moved 3.38 liters. To find the density of that, then, we take our mass, which is 65.14 kilograms, divided by the liters, or the volume, 3.38, and what is that object? And you're going to choose the right one. I'm going to choose this one. It is not correct, but I just want to be able to move on. Now, if I know this is 1, what I could do is go back using the table. If it's 1, then I would say this is water. But you can use this table. It's not going to be water. But you can use this table to figure out what the item is for the next one. So if I was saying this one, okay, well, it's water. And again, these are, you know what, I'll just give you the right answers, just because it is a key. If I divide this out, it's 19.3 grams per cubic centimeter. And for some reason, that's not on the sheet. I have to fix that. That should be gold. 19.3 grams per cubic centimeter or kilograms per liter. They are the same measurement if you convert them. That should be gold. I need to fix that question. Okay, so then we go back, move our table if we want, if it's in the way. Take A out of the water. Take B, place it on my scale. Let go of it. So if I move it, it goes to 0.64 kilograms. That's its mass. That's how much material it's made out of. Now, here's where you have to be careful. If I drop this in the water, well, I have a problem. It floats. And I see my volume is changing. If I keep dropping it in the water, and if this is amusing to you, you can do this on your own. It doesn't really help the lab, but you can see. Now, if I want the full volume of this object, I have to have it completely submerged. So right now it's at 100 liters. If I put it fully underwater, I get exactly 1 liter. Notice how if I let it go, it hovers at about 0.65, 0.6. But again, not all of it is in the water, so that's not the full volume. That's the volume of the block that's in the water. So if I want the full block of the volume of the block, I'll have the block all the way underwater, which is 1. So if I put that in the formula, again, if I have a mass of 0.64, and I divide that by 1, I get 1, or 0.64. Okay, I use the table. So what is that material? What is 0.64? Sorry, I hit it. That is an apple. Okay, so what is that material? It is an apple. Okay, hit next. Again, not going to have to watch this video, but please watch it. It's talking about density of solids and liquids because there's a difference between them. But density is really density. Now, this relates to a concept about sinking and floating. The density of pure water is close to 1 gram per milliliter, 1 gram per cubic centimeter. A milliliter and a cubic centimeter are the same thing. If you place an object that is more dense than 1 gram per milliliter in water, then it's going to sink because it's more dense than the water it's in. If you place an object that is less dense than 1 gram per cubic centimeter in the water, it will float because it is less dense than the water it's in. And we just saw that. When I took the gold and I dropped it in there, it sank right to the bottom. It had a density of 19.3 grams per cubic centimeter. That means it's more dense than water, so it sinks to the bottom. When I used the apple, it was 0.64 grams per cubic centimeter. So when I dropped that in, it floated. Why? Because it's less dense than water. Remember, I'm not going to read all this, but again, the formula for density is mass divided by volume. If you have those 3 units, you can solve the rest. Now, you might need a calculator for this, but if you have a block of wood with a mass of 13.3 grams and a volume of 15.6 grams per milliliter, what is its density? Remember, density is mass. What? This is wrong. That should be 50.6 milliliters. But anyway, what's that going to change what we're doing? If I divide mass divided by volume, 13.3 divided by 15.6, and I'm sorry, I'm not a math teacher. I'm going to have to use my calculator for this. So you have to wait while I find my calculator. So 13.3 divided by 15.6, they get 0.85, which is the density of that material. Okay, so based on this answer, would this float or sink? Well, remember, the bar is 1 gram per milliliter. If it's higher than that bar, it's going to float. If it's lower than that bar, if it's bigger than that bar, it's going to sink. Well, 0.85 is less than 1, so this one is going to float at the top. If you have a rubber ball that has a mass of 5.9 grams and a volume of 4.9 grams, this is wrong. I didn't write this, so I apologize. I will fix this. Volume is never grams per milliliter. This is a density unit. It should just be milliliters. So number's not going to change. It's going to be mass divided by volume. So, and it won't look the same. I'm going to go back and fix this as soon as I'm done with going through the key here. 5.9 divided by 4.9. And I get 1.2. So that's this one. Now, based on that previous question, what will that ball do? Will it sink or float? Well, if it has a density of more than 1 gram per milliliter, it is going to sink to the bottom. Have a candle with a mass of 10.4 grams and a volume of 10.6 milliliters. That's irritating me now. So 10.4, which is my mass. Let's do this right. I'm going to divide that by my volume, which is 10.6. And I get 0.98. Okay. And again, now this is pretty close to water, but because it's less than water, it's going to float to the top. Now, if it's exactly 1, then yeah, it's going to go ahead and it's going to suspend in the middle, but it's not exactly 1. It's less than 1, so it will float to the top. Here's the way of looking at it. You are very close to the density of water, and you can prove this because if you ever sat at the side of a pool, if you let out all your air and you let go to the side of the pool, you will sink to the bottom because you're more dense than the water. If you take a deep breath and let go of the side of the pool, you will float and hold it because you have opened your your chest and created an air cavity, which has increased your volume, decreased your density, which means you're less dense than the water, which means you float. So if you ever sat around playing Dead Man in the Water, that's because you're pretty close to the density of water. You can check those answers on that website if you choose. Now, these videos are only if you want to. They are not required. But if you want to look, review, and learn about some more concepts of density, we will be doing a bigger lab on this tomorrow. But that is the homework for today. If you have any questions, please ask. I will make those corrections so they aren't confusing. But otherwise, that is the activity. Make sure you submit it, and you are done for the day. I hope that was a little useful. You can always go back and practice the and play around with the simulation more if you want to just practice. There's a couple different settings on you can play with. But otherwise, have a wonderful day.